Hello everybody. I cannot contain my excitement for the fact that it's Wednesday, it's 1 p.m, and I'm actually joined by a real life human being for the first time in ages. Hello Robert. Robert Nagy is here with me in real life, ladies and gentlemen, and I must say you're slightly better looking in real life than you seem on the screen.
Better resolution.
Probably. Anyway, we're here today to talk about containers and microservices and some of the myths, etc. about that. So Robert's going to do some stuff on the whiteboard and show us a little bit around some of those questions. If you've got any questions, I've got a computer down here. I can see your questions. So if you ask the questions, please feel free. No problem at all. Right, so first question. So we get on with it. One of the common confusions around microservices, containers, and virtual machines is what's the difference between things like virtual machines and container microservices. So can you first of all just explain a little bit about that? And I'll step over here.
Sure. So containers and virtual machines are conceptually very similar. So they are both about running software on a virtualized environment, which means that you can run multiple instances of a service on the same machines. In the past, in the old days, you would have one machine per each service, and then you would often over-provision the hardware, and you would have lots of hardware where you're not using the full power. And also you lose a lot of resilience, etc., that you can get with virtualization. So going back to containers and VMs. So as I said before, they are conceptually very similar. They try to solve similar problems, but you can think of containers as a very lightweight virtual machine, which has some advantages we will go into later, but primarily it can reduce the memory, the storage requirements, and the container is also much quicker to start up and shut down. So how do they differ technically? I'm going to try to keep it simple, but basically you have your hardware here in the bottom. So this is your hardware. And in the case of a virtual machine, you have something called a hypervisor. I'm just going to call it hyper here. That lives on top of the hardware. And this hypervisor then hosts a full operating system. So every virtual machine is basically a full operating system and needs to contain everything. And then on top of the OS, you have your runtime, and then finally your application.
Just because I'm a bit dumb, what does runtime mean?
So a runtime is all the libraries and code that your application needs to run stuff.
Okay.
So it can be operating system libraries, it can be drivers, it can be, for example, Node.js or the .NET runtime, basically code that your code uses to run.
And that sits on top of the OS?
Yes, that sits on top of the OS. And you can think of, so this is the VM way. And in a virtual machine, basically you're virtualizing the hardware. So the operating system thinks that it's running on its own hardware, but it's actually just running on some kind of virtual hardware. Now, as you can see here, this basically needs to boot up an entire OS, and you need to have an entire OS image for every service you want to deploy in this fashion. Now, in the case of containers, just like before, you have the hardware here. I won't write it out.
Okay.
Then you have a container engine.
How does a container engine differ to the hypervisor then?
Actually, sorry. Very good question.
Let me help you out there, Robert. Oh, our whiteboard is failing miserably. Right, there we go.
Thank you, Adam. Actually, you have your...
You need some rehearsal time.
You have the operating system first.
Yep.
And then you have the container engine.
So that's sitting on top of the operating system?
Yes.
Okay. Engine, yeah. He's writing some files?
Yes. And then you have your runtimes on top of that. And then your app here. So what's the difference here? Well, now we're going from virtualizing the hardware for the operating system to virtualizing the operating system for the runtime.
Right.
Right? So now the image no longer needs to contain the whole operating system and everything around it, and you can boot much quicker.
So each one of these instances here for one app would require a single OS. Whereas what's happening here is that one OS is sitting underneath everything, and all the containers are running on top of one single OS. So you're only loading that once.
Yes. Okay. And there are advantages, like it's easier to configure just one, the underlying OS rather than having to configure every OS separately. There are pros and cons to this, of course, but in general, this is a faster way to do it. You can do it. I mean, this is more powerful, of course, because you can modify and virtualize the entire operating system and the hardware below it. But usually you don't need that power.
Does this not create points of failure? I mean, if you have an OS crash or something in one OS?
Of course, yes. You might miss configuring a certain parameter in one of these
OSs.
Images, right? While in here, you are sure that when you set up the machine, this is the OS, and this has security advantages because you can in your base OS do your security configurations and permissions, etc.
In one place.
In one place, and be sure that whenever somebody runs something on your servers, they can't get out of that sandbox.
Okay.
While here you need to sandbox on an image basis.
Yeah. Now we're talking and we're ignoring our audience. Sorry, audience.
Yeah. So this is the.
So that's the virtual machine
container.
Okay. So what I'm going to do now is I'm going to destroy all of your excellent explanation there. And we'll start again.
Oh no.
So what exactly is a container? And can you give me some examples of kind of like how we use containers inside Next? So to me, what's that? It's a bucket or is it like a shipping container?
Well, in more practical terms, one container is one service. It's a piece of software that provides a certain functionality. And usually you want to be able to, so in the old times, you would usually make software a monolith. Like you would have this big server running a single application, and that application in turn, have lots of subsystems, right? And in those days, if one of these subsystems fail, that could crash the entire thing.
All right. Okay.
And then you don't have a nice failure mode where just the specific part that failed is restarted or recovered. Now you have to so if you're in the middle of a broadcast and the robotics controller fails, that would crash the entire system. While in a more separated microservice architecture, yes, you lose control over your robots, but the broadcast or the system as a whole still continues to function. So,
he's got it figured out. Look, he learns fast.
I'm learning. So, containers are just a way to split up into microservices. Like you could have your big OS, and then you just start multiple applications in that OS. Right?
That would be like the virtual machine scenario, wouldn't it?
You could do that in a virtual machine as well. Of course, you could in a virtual machine also create one virtual machine for each application.
For each application.
But then you go with this rather high overhead. But this is also one way to run. Now, the problem here is these different applications might require different, it might require a database or some different configuration, etc. And then all of a sudden you have to make sure that this operating system and the way it's set up works the same. All of your different services work the same. And all the dependencies and runtimes, etc. are supported. And also, like if you need to update something on the OS, you have to kill everything and run it up again. So a microservice kind of separates things out a little bit like, having one machine for each service, right? So you have a service 1 and service 2. They are running their own machines. You could do this in the old times as well. You would have one computer per service, right? And then one step further, you have one virtual machine per service. And nowadays you have one container base per service. And all of these steps basically allows you to make it more fine-grained in practical deployments, right? So you have your little service here. or microservice running in a container. And if one fails, you can quickly restart it while the other one is still running. Now, in Next, we often have several instances of the same service running in different containers. So, for example, this could be one render service 1 and render service 2. Now, if one of them crashes or we're just upgrading, then we will take one down, upgrade that one, and then take the next one down and upgrade that one. And that way we can reach 0 downtime deployments, which is very nice. In the middle of a broadcast, there is a critical bug that needs to be fixed, and we can deploy and fix it without anyone noticing. Yeah, of course, they notice that all of a sudden things are working, or there's specific missing feature or something all of a sudden jumps up. So that gives us some power. And of course, now when you're talking about containers, one big advantage of containers is the scheduling around it. So you can tell your system of containers that you want 2 instances of this render service running. Now, if a hardware fails, you can make it so it automatically gets respawned on some different hardware. So you get to these automatic failovers that are very nice, and then you can have fail and quickly recover.
Yeah, remind me about that when we get to the cloud stuff. So what exactly are the practical advantages of running with these containerized services, so to speak?
Yeah, I was a little into that. The main advantage is a little bit what I just went into, the scheduling of things. You can quickly upgrade, so you can quickly kill a service and get it up and running again quickly with minimal downtime. You can have failovers quickly with minimal downtime.
You can also split between servers.
Yes, and then you can, of course,
in an on-prem environment.
Yeah, you can have load balancing.
Yeah.
So, and you can have dynamic load balancing. So, for example, you're running 2 render services, render 1 and render 2, and all of a sudden the load goes up. Well, you can spawn, if you have, depending on your hardware, you could, spawn down some other service that doesn't need so much power right now, and then spawn up the render service.
And that would be render service 3, right? Yeah, so they're just replicating, and then that's elasticity within the server.
Yeah. So, for example, this server here may sometimes run a streaming server, right? But in this specific case, maybe you're in the middle of the day, you're not broadcasting so much, you're more ingesting material and working with it. Then you could, kill this, or maybe there's not just load enough, and then you can dynamically spawn up a new render service.
And use that resource that's not being used for rendering just in that instance.
Yes.
Yeah, so you can use that for elasticity. And we're going to talk a bit about that with the cloud as well in a minute, but I don't want to jump the gun. Okay, now. Sorry. May I interrupt?
So the really nice things with containerized environment, you can do this with virtual machines as well, but it's not as common, and I don't think tooling is quite there, is, for example, when we in nxtedition deploy an entirely new system, for us it's a press of a button. In the traditional system, you would have the machine, you need to go in and install the right drivers.
You have to get that long serial code and so on.
You have to install the database and make sure everything is configured properly. And that can take days depending on how complex of a system you have. But the way we do installations using something called Docker Swarm is our clients basically receive their hardware 1, hardware 2, etc. They join something we call a swarm. And then basically we run our deployment script, which tells, okay, we need this many of this service on this type of hardware, and then it automatically installs and deploys everything because everything is already inside of the container.
So the containers themselves, they're actually, what's the right word I'm looking for?
They're pre-configured, basically.
Yeah. So they're ready to go already, the code-wise, and we just deploy a bunch of them onto a resource, so to speak. Yeah.
So they're resource pools.
Yeah. Don't draw on my logo anymore. I get upset if you draw on my logo. I'm marketing, remember? Right, so there's different types of these things. So for instance, as you say, we use Docker Swarm.
Yes.
But there's also something called Kubernetes, and I've never understood that. So perhaps you could explain to me the difference between Docker and Kubernetes.
Yeah, so both, Docker is a container runtime, while Kubernetes is, I would call it a container environment or scheduler. We have container runtimes, where Docker is one. But there are others as well. Right? And then there's Kubernetes here that
He's still getting used to the pen.
It's too long to write. But Kubernetes basically manages containers, right?
Okay.
And Docker Swarm does the same.
Okay. So effectively, Docker Swarm and Kubernetes are the same thing, but Kubernetes isn't Docker. So
Yeah. So they are conceptually the same thing. Mm-hmm. Now, Kubernetes is developed by Google.
Okay.
So it's very good. It's very powerful, and they use it for their enterprise server, cloud, etc. Mm-hmm. So Kubernetes is very powerful. However, it's a little complicated.
Okay.
Right. So, and in complexity, there's risk and potential problems. So with great power comes great responsibility.
I see.
Right? And if you don't need that power, for example, for, an on-prem installation for a broadcaster is relatively speaking to a big cloud installation in total different ballparks, right?
Yes, exactly.
So we choose to go with the simpler, less powerful, but simpler scheduler called Docker Swarm.
And that reduces the complexity, which therefore reduces the risk.
Yes.
Because we're all about quality of service.
Yes.
Right, so now we get into a really interesting discussion. Mm-hmm. How does this work in relation, so we've been talking mostly about on-prem, so let's talk about the cloud. If I'm deploying all of these Docker containers, right, on a server, and if I deploy them in the cloud, what's the difference?
So there really isn't any. At this point, as I told you before, you have this resource pool of hardware. Mm-hmm. Conceptually speaking, where this resource pool lives doesn't matter so much for the deployment in itself. There are, of course, big differences in other points. But there is no fundamental difference. So basically, in the eyes of Kubernetes or Docker, these are just hardwares in their resource pool, and where they live is irrelevant. You could actually create a resource pool where some of the hardware is on-prem and some of it is on Amazon. Mm-hmm. And then you can put labels on them, on those nodes, and then Docker knows, okay, am I allowed to put these services in the cloud or not, or should they live on-prem or not?
So you could build a workflow around it based on these labels of, okay, if this, then that, right?
Yes,
so
exactly.
If this, then put that in AWS or process that in AWS or process it on-prem. So that should allow for cloud bursting on a hybrid environment, right? You could cloud burst on renders, for instance.
Yeah, for example, we had this example where you could run out the render on a machine that has less load. Well, here you can put it out on Amazon. Mm-hmm. So, of course, the advantages of running in the cloud is when you have elasticity, right? If you're running the same servers 24/7, then an on-prem solution is a lot cheaper because running a server on-prem is cheaper per hour than running it on Amazon. The advantage of Amazon is the elasticity. So let's say you have a maximum burst of, you need 100 render servers, but you only need them for an hour, right? Amazon is perfect. Rather than having 100 servers running 24/7 here locally, you just have those 100 servers when you need them. And this is where the power Amazon comes. And if you build up your environment like this, it is a hybrid cloud environment. When you are out of resources on-prem, then you can scale out to the cloud. So for example, renders are perfect for this. So you have a breaking news, and you're ingesting material at 10 times what your usual rate, and all of a sudden you can't keep up with it. Scale out to the cloud.
Yeah.
Perfect.
Yeah. Or use transcodeless playback in Next.
Yes. If you have it next.
And something we're going to talk about, I think, in another one is we're also going to look into a little bit about how we can do these cloud bursts using blockchain technology and some of the sorry, I shouldn't say that, the BC word, that the transcoding in the cloud using blockchain. So I've got really confused there. Right, now, a question I get asked a lot, and I really do get asked this a lot, and it's a question that a lot of broadcasters tend to ask, particularly in demos and stuff like that, is that, people want to get these sort of best of breed solutions, right? So they want to buy a container from vendor one who's good at this, and they want to buy a container from vendor two that's good at that, and a container that's good at the other thing from vendor three. So now I've got 3 different containers. So how do I, as a broadcaster, get these 3 containers to talk to each other in the cloud, for instance?
Well, you kind of come back to the traditional problem here. You have, in the broadcasting world and in many worlds as well, where you have different boxes from different vendors, and all of a sudden all of these needs to be able to talk with each other.
But my question is, if they're containers, this should be relatively straightforward.
Actually, the containerizing or not doesn't actually make any difference for the communication between the services.
Right.
So yes, maybe you can have them running in the same virtual network, so you have an easier networking setup, but it only helps you with the infrastructure around it. So it's easier to deploy these different services out on your resource pool, because you don't have to buy one server for each.
Exactly.
But it doesn't actually do anything in terms of helping these services communicate.
So there's no, in Docker or in Docker Swarms or in Kubernetes, there's no built-in communication that's kind of standardized between these containers. No. So how do you get them to talk to each other without any faults or any problems?
Difficult.
Difficult.
Yes. So you basically have to create some kind of service that acts as a translator.
So you need like a protocol.
Yeah. Here and
now
then,
we're getting back to where we were before.
and then you need so you end up with a lot of complication.
But does that exist? Is anybody working on that?
Well, indirectly, maybe they're not working in containers, but as I said, whether it's container or not, it doesn't really make a difference here. You have to make some kind of software that does the glue.
So like vendor A and vendor B, just write A and B on here, right? So this is my take on it, all right? And please bear in mind, I am not a developer. But my take on it, as I understand it, is vendor A and vendor B, in order to talk to each other in these containers, will have to create an API into vendor A from vendor B and vice versa. So at the moment, because this standard to talk doesn't exist. So each one needs API calls.
It depends. It can, if it's only B that needs to talk with A, then you write a little box here that translates back and forth, or you can write it on this side. You usually don't need to write it on both sides, but then you have the problem, okay, what happens when A wants to talk with D?
Yeah.
Where do you put these translation boxes?
Yeah, and it would be a different thing you would have to say to D in a different way than you have to say to B, for instance.
Yeah.
Right.
And then that's where we come into these protocols like the MOS protocol, right? So MOS is a way to try to standardize some of these controls between. Of course, MOS in itself is not secure. So then you have to be careful how you set up your virtual network to make sure nobody can sniff your MOS protocol. Possible, but you have to keep tongue
security tight. Yeah.
Tight. The other problem with, for example, a protocol with MOS is, yes, you've standardized a protocol, but what does that mean? So what does the different commands mean in different domains, right? And then you kind of end up with these kind of boxes anyway. In some
so you kind of sort of replicate what we've already got on the ground into the cloud and some of the issues that draws up.
Yes.
That's the great thing about standards. There's so many of them. Right, actually that's my last question. So I'm just going to pop over here and have a look and see if anybody's asked any questions. I can't see any questions coming from LinkedIn. Let me see. Interesting things on the chat in YouTube, but I don't think that's got anything to do. So I think we're done. So thank you, Robert. That was most enlightening. I enjoyed that very much. We'll be back next week. If you're watching on YouTube, please subscribe, because we're going through the roof on subscribers this week, and that's quite impressive. So more of that, please. And next week's, we haven't decided what that is, but I will post that straight after this. So thanks very much, everybody, and have a good day.